Hello everyone, my name is Devansh masani. I am a first year student at IIT Roorkee, and today I am going to show you my C++ project, which is a sliding number puzzle game. I have made the game entirely in C++. So let's get started. I will give you a brief introduction about my game and how to play it. So first of all, what is a number puzzle game? The number puzzle game is a classical and a logic based game. So it consists of a grid of a number square tiles in a frame with one tile missing. I will just show you screenshot of my game. So this is a, for example, a 4 cross 4 number puzzle in which there is a grid of 16 boxes which we are going to call tiles. So there is an empty or missing tile which we call the empty tile, and here there are numbers from 1 to 15 and they are jumbled. So the main objective of our game is to rearrange these numbers in a numerical order from 1 to 15 in an increasing order from left to right. So first number will be 1, 2, 3 until 15. How do we do that? So first let's understand it how to move the tiles by a 3D model. Like this is a 3D model and this is an empty tile, or we can call it an empty space. The tiles adjacent to the empty space can be moved and the tiles cannot be moved. So when we just slide the tile having six number like this, and then slide the number 5 and then slide the number 4. So that's how we can actually rearrange the numbers. So I will just replicate this motion by using the swap function in our program. I will tell you I will tell you in this video. So let's get in next. Okay, these are the features of my game. I actually don't want to make a simple game and actually solve the puzzle, but I want to build a gaming experience. So I have included many more features to the game. The first feature is the main menu feature. It asks the player whether he want to place the game, whether he want to show the instruction, or whether he want to quit the game. The next feature is the difficulty feature. I don't want my game to actually just have a 4 cross 4 number grid, so this will be a boring for the player. Instead, I just have a easy, hard and a normal mode, which is like a 3 cross 3 puzzle, 4 cross 4 puzzle, 5 cross 5 puzzle. For that, I have uses of vectors for creating the board, not the arrays. Next is the undo feature. The undo feature allows the player to actually undo his move. The next two features are actually added so to make a competitive spirit in the game. The first feature is the move count feature. What does it do is that it tells the player the number of moves he had played till now, and the move time feature tells the number of seconds he has been spent in playing. The next is a always solvable game. This is a crucial feature of my game. I will tell you a fun fact why I needed that feature. When you just randomly pick up the tiles and arrange in a grid, so there's a 50% possibility that you will create a puzzle which is impossible to solve. So to avoid this problem, I just have another approach in building the board. We just started from a solved puzzle. I just tell the program that make 100 to 200 random moves so that every move is a reversible move, and that guarantees that the puzzle will always be a solvable puzzle. The next is I will be adding a colorful display. In the console-based games, we cannot actually add a graphically oriented. We can we cannot actually add them graphics. So I have used the colorful displays to add colors to them. So it will be look visually appealing to the player. Next are the libraries that I will use for the my game. The first library is the most common library that is used in every C++ program, which is the IO-Stream library. It stands for Input Auto Stream Library. It allows the program to interact with the user. It allows the function of cout and cin, which we are using to displaying the screen and also in taking the input from the user. The next two libraries I have used is to make our shuffling the board possible. The first is the C standard library. It provides us the random function and the S random function, and also a command which is system clear command. This command actually ensures to have a smooth gameplay of the game. Like it actually after every move clear the console screen and then new screen is actually generated, so the game looks smooth. Next, I will explain why I have uses this ctime library and then C standard library for generating a random number, random function and S random function times zero function. So random function is used to generate a random number in C++ and in many other languages. But how does it do? And does the computer actually produce a real random number? So answer is no. The computer actually produces pseudo random numbers. How is that? I will explain. First of all, the random number actually have a seed or a starting point. For example, it has a starting point as an integer 4. When we call the random function in a program, it actually have a set of calculation which it perform on the integer 4 and produce another number, let it be a 60. So it will print the number 60 on the screen, and then we again call the random function. It again does the same set of calculation but now on the number 60 and create a number 70. So it looks like that we are generating a random numbers, but they are the same set of sequence. So the problem here it is that when we actually stop the program and again run the program, then what happen is that these set of sequence of random numbers will always be seen. Like in the first have 60 and a 70. When we stop the program and again run the program, we again got the number 60 and a 70. So how to solve it? We are solving it by using the srandom function integrating with the time zero function. What does the srandom function does is that srandom function actually initializes seed or the starting point for the random function. By the helping of a time zero function, the time zero function actually creates an integer value of represent the current system time. So in detail, if I want to explain you the time zero function is that it actually has the number of seconds that have passed from January 1, 1940 till now. So at every instant, the number of seconds passed is a unique number. So it is a seed that is seeded by the s random to the random function, and then this actually guarantees that the numbers we will be generating by the random function, the set of numbers will always be unique, as the seed is always unique. Now I will just explain why we use algorithm library. Algorithm library is actually a collection of a preset return functions. Like I will use swap function. We have used swap function to actually essentially exchange the position of the empty space with an adjacent type. So I've used this library. Next, I've used the string library. I've used the string library for using the string data type to store the NSI escape codes that I'll be explaining in the upcoming slides. Next is the stack library. The stack library gives us the stack container, which actually has a very unique data structure, which follows the rule of last in first out data structure. What happens is that I will explain you with an example. Suppose imagine a stack of books. First you place the first book, then second book, then third book, then fourth book, and the last book you have placed is the fifth book. Whenever you have to take a book from the stack, you will just start from the top and take the fifth book. So what happened is that the book which was kept last in was the first out book. So it is called the last in first out data structure. This is a very crucial for undo feature to happen in a game. Next is the vector library. I have used this to use the vector for having the difficulty feature. I will explain the use of chrono library. The chrono library is used to measure the time accurately. In, and actually in the game, I have used the in-game timer feature. This is actually possible with the help of the chrono library. Next are the libraries input-output manipulator and the limit library. The input-output manipulator library is used for formatting the output. Like in our program, we have used a set width function in the display function. So this ensures that the every number like a single digit number or double digit number occupies the same amount of space so that the grid is a perfectly aligned and is visually appealing also. Next is the limit library. The limit library provides the numeric limit class which gives us information about the properties of data types as the maximum value. So it is used as like having the maximum value of a particular data type. For example, for int, we have to create the maximum data it can store. So we will be using the limit library. We are using inner line of scene.ignore numeric limit stream size maximum this. It actually clear the input buffer. Now I am going to explain you what are the NSI codes. These NSI codes are used for a more stylish display. Like in our program, I have used it for the colorful display. First of all, these are a set of characters that are taken as a command for the compiler. We are storing these characters in the color blue light type variables like we have actually stated the variables color blue, color green and color yellow. The type is of string. So These NSI codes are stored in the variables, and whenever we want to use these codes, we directly have to use this color blue. We are actually declaring these variables as a constant variables as we do not want in our program so that no one can change these variables. Next is that they are using as a global variable because we actually want it throughout our program so that we can use it. Let's start with slash 033. It's a special type of character which is called the escape character, and it actually has given a warning to the compiler that whatever the characters that are following are actually a command, not a text. So then we write a square bracket which is called a control sequence introducer. It actually indicates that the command has started. Next are the color codes. These are the color codes for the different colors. Like for blue, we are writing 94. For green, we are writing 92. And for yellow, we are writing 93. And also for the default color, we are writing 0. And at last, we are just writing the M. This M signifies the command type, like what type of command it is. For now, it is a command like set graphic rendition as we are using it for the color. Okay, now next. First, I will introduce you about what are classes. So class, you can imagine class is like a blueprint or a template for creating objects. It is actually user-defined data types, and it actually bundles all the data members and the functions in a one place so that they can be used directly from that place. Think of a class like a blueprint of a car. What a car has. The car has some data like the number of wheels, brakes, and the color of the car. And it has a functions like to brake, to accelerate, to take a turn. So these things are stated in the blueprint of a car. So whenever you have to make a car, we have to use this blueprint for the specific model of the car. This is actually used in our program for the classes. What are the advantages of using the class? There are three advantages of using the class. First is the organization modularity. A puzzle is a complex thing with data and actions it can perform. When we are actually declaring the class puzzles, it has a many more things like it has data members like empty tile and the coordinates of the empty tile like empty row and empty column, the size of the grid, and it has a various functions like the play game functions, the setting the board function. So we just have to organize them into at the same place. So we are using the classes, and another advantage is that it is an advantage of encapsulation. Encapsulation allows the class to actually hide the internal details like how the puzzle works like board, empty row and move history from the outside world like the main function. The main function can only call these functions. He doesn't know how the function are being operated and what the function does. He actually only give the input and call the functions so that these variables cannot be changes directly in the main function. This protects the data from accidental corruption and make the code more robust. Second, the third advantage is the maintainability. When changes are needed, like it is adding a new feature to the game or changing a feature. So you just don't have to just entirely change the code. You just have to add and the class declare the function and then declare the definition of the function. This will create a new feature which will actually reduce the. So let's look inside my puzzle class. As I have mentioned, all the critical data are kept private. This is encapsulation action. These private variables are the brains of the game. They hold its entire state. First, we have the board itself. This is a vector int. Using a vector of vectors is what makes the difficulty feature possible. It creates a dynamic 2D grid that can easily be 3 cross 3, 4 cross 4 or 5 cross 5 puzzle. Next, we have the m size variable to store the dimension, empty and empty column to instantly know where the blank space or the empty tile is there. Then we have the stack character move history. This is a complete engine for the undo feature. Every time you make a valid move, the code pushes the opposite move onto the stack. If you hit undo, the game just pops the last root from the stack and executes it, perfectly reversing the state. And finally, there is a start time. This is a chrono time point, which is basically a high precision timestamp. When the player makes their first very move, this variable records the exact moment. The timer you see is just the live difference between a now and this start time. Now, next to the another slide. So We have seen the private data. Now let's look at the public functions. The first, we will start with the constructor. Puzzle end size. This is what creates the puzzle object. First, we start a new game. We pass in a size like 3 or for 3 cross 3, 4 for 4 cross 5. This enables the difficulty feature. Next is the void display constant. This function is responsible for drawing the entire game board to the console. As the slide notes, it marks as constant, which is a C++ promise that this function only reads the board data and will not change anything. Then we have the void shuffle function. This function is responsible for scrambling the board. It works by simply calling the move tile function hundred of times with random directions. And that brings us to the most important function, bool move tile. This is a code logic for the entire game. It takes a character for direction like WASD, but notice this boot has a record move equals to true. This is a very important trick. When the player makes a move, this is true, but when the game is shuffling, we set this to false. This prevents a hundred of shuffling moves from being added to the undo history. The undo function also uses this false flag to avoid recording an undo as a new move. The rest of the function manages the game state. Itself is a simple clock to see if all the tiles are in the correct order or not. Undo move is what makes the undo feature work. It just pop the last move from a private stack and call move tile to reverse it. Then get elapsed time simply returns the total time passed since the timer started. So by combining these public functions with the private data, we have a complete organized and robust class that can run the entire program. Next is we have the constructor. This is the most important function. This is a function that called every time when we create a new puzzle object. The first thing you will notice is the bit of syntax, m size. This is a member initialization list. It's a modern and efficient C++ feature that initializes our private m size variable before the main body of the constructor even runs. Inside the constructor, the first line is crucial, board.resize. This is where dynamic 2D grid is actually built. It resizes the outer vector to m size, are rows, and then it fills the vector with m size. New empty vectors are columns. The result is a perfect empty grid of the correct size, whether it is 3 cross 3 or 4 cross 5. With a grid created, these nested for loop runs. They simply walk through every cell and fill it with an increasing count like 1, 2, 3, and so on. Finally, the last few lines set up the game starting state. We set the empty row and empty column to be the very last position and then set the last position on the board to 0. Like initially it was 16, we are initializing to 0. It represents our empty space. We also set time started to false. So when this constructor is finished, we have a brand new perfectly solved puzzle just like the 4 cross 4 puzzle, ready to be solved. Now, we have seen how the puzzle is created in a solved state, but how do we scramble it? That's the job of the shuffle function. This shuffle function runs for a loop that makes a huge number of random moves. For a 4 cross 4 grid, this is a 16 into 20 times, which is a 320 moves, ensuring the board is a well shuffled inside the loop. It just picks a random direction and call move tile. But notice that false parameter, this is a record move flag we talk about. By passing false, we could move not to any of these 320 shuffling moves to the undo stack. This is the key to my always solvable shuffle game. Finally, after the shuffling is done, the code does a quick cleanup. It manually clears the move history stack just to be safe, and most importantly, it sets the time started to false. This ensures that the shuffle function doesn't start the player's clock, which only began when they make their first move. Now, we are going to look at one of the most important functions for the most is the display function. This function runs every single time the player makes a move. The very first line is actually a command. What does the command say is that this is a it tells the operating system to work the console screen. CLS is for the command for Windows and CLS is the command for the Linux and Mac OS. The the operator which is represented by the two lines is the called the OR operator, which actually tells that whether the first one is true or the second one is true. We have to run that function. This makes my program cross-platform is the key to create the illusion of animation. We are not moving a tile, we are clearing the screen and redrawing the entire board in its new position. After clearing the screen, the rest of the code is just count statements. It starts by painting the tile in color yellow. Then it uses the two nested for loops to iterate through every single cell of the board. Inside the loops, it prints the grid line using plus and minus, and of course uses color blue and color green to draw the colored number and borders. The final result is a clean and a colorful grid. So you just see on the right of the screen which get freshly drawn. Every single time you press a start. So we just saw how the display function creates a screen and start drawing the grid. This will show the most important part, the code inside the loop that draws each cell. As the code iterates through every row and column, it hit this if a statement. If the cell board is equal to 0, we treat it as an empty space and just print a blank. And we print the color code to change the text color. We also use set width function to which stands for the set width function to force a number to take up exactly two spaces for aligning the single digit and double digits. For this, we print the number then itself, and actually then we exactly reset the color to color blue to print the final, and then the slash for board for the red cell. After the nested loop had all finished, our final loop runs to print the bottom border of the grid, closing it off. By combining the green screen color, the NSI colors, and the set width function formatting, we get a clean, professional, and perfectly aligned result you see on the right. Next, we are talking about the move type function. This takes two parameters, character direction and bool record move, and then it actually initializes two integers. Like first, it actually stores the coordinates of the empty tile in target row and target column, and actually initializes a opposite move, which is a character data type, and we are initializing it for 0 because we have to kept it at the starting. We have to kept it as an empty character. Then we will just have we just have the conditions like direction equals to W or direction equals to capital W. We just actually have to plus the target rows. Like suppose this is the empty tile here, and the target row is also the coordinates here. If we place the W, then we have to move it upwards. So how can we move it upwards? We have to just change the target row coordinates to this. Like this is the target row 3. We have to just update it to target row 4. So now the target row coordinates are here and the empty tile functions are here. Then we can directly swap that, which will be I will show in the next slide. And also we have to just record the opposite move. If you have placed W, then we have to record the move S, which will be used in the undo feature. This similarly you can use for W, S, A and D. All are just like same. Then if the player just enter a number which is not matching to these numbers, then it will return false and the move type function will not be executed. Next thing is that it will check the target row and the target row column, like if they are inside the grid or not. Like suppose there is an empty tile here and we are just presses the S key, which is the downward. So target row should be here, but this is out of the boot. So this move is an invalid move. But how can we say that? So we have taken the conditions like target row should be from 0 to 3 as and size equals to 4. So target row should be 0 to 3 as 0, 1 to 3 and target column should be from 0 to 3. If these conditions satisfied, then only the condition will actually exist. If record move and time started, this is another condition. The record move is true and the time started is we have declared false. So false first will be true. And we will just storing the instant time by using a static clock in the start time variable. And actually we just tell change the boolean timer started to true so that whenever the compiler again goes to this condition, it will not execute it as the time will only be started on the first half of the game. Then we will just swap the empty row and the target column and thus update the coordinates of the empty row to the target row or column. And if this is a valid move by saying the record move is true, then we will just put it into the undo move. Next, we will just say that the function has executed truly and we have made a move. But what if these return types are written in the if conditions? So the compiler thinks that what if any of these are not executed? So we have to just write it for a safety, a return false statement. We know that the compiler will not reach here, but for the safety and for the compiler to run the program, we just have to write this. So after every single move the player makes, the main loop ends to ask a critical question. Is the game over? This is the job of the install function. The function only purpose to check if the current state of the boot, like the scramble one on the top right, matches the boot state shown on the bottom. The logic is very straightforward. It initializes a counter C to 1. It then uses the nested for loops to walk through every single cell of the game starting from the top left. Inside the loop, it performs the main function if boot this checks the number if is not equal to C and then C++. This simply asks is the cell at 0, 0 boot equal to 1? Is the cell at 0, 1 equals to 2? Is the cell at 0, 2 equals to 3 and so on. If it ever finds a mismatch like on the top right boot where 0, 0 is 14 and instead of 1 it immediately stops and returns false. This game is over. This game is not over. But if it goes through the whole book and all the numbers match, it hit one specific case, the very last cell, when our counter C equals the maximum value which equals to 16, it checks if the last cell is 0 or not. If all the numbers from 1 to 15 are in order and the last cell is 0, the game returns true. The game loops stop, the timer is frozen and the player gets a congratulation message. And finally, let's look at the function that runs on game stop first. Get elapsed time. It's called after every move to update the time display for the player. The logic here is very straightforward. As the slide shows, first it checks if timer has started or not. So if timer has started not and is equals to true, then it will just return 0. If the timer is started, so this will not execute it and this line of the code will execute it. It can calculate the duration by simply subtracting the start time which we have saved on the first move from the end time. Finally, this duration is a high precision value, so the last line uses chrono duration cast so to convert it into simple whole seconds and return that number. This simple function is what provides the life timer, adding that extra layer of challenge to the game. Now, we will be moving to the undo move. One of my favorite features. This is where the stack data structure we talk about finally comes into play. The logic is broken down on the right. Let's walk through the boot. First, a safety check. The boot checks if the move history is empty or not. If the stack of the moves is empty, means the player is at the start or has undo all other their moves. It means no moves to undo and simply returns. There's a and this is for a break like the compiler will actually clear the screen. So by using this for loop, we are forcing the compiler to wait for some seconds. Now, if there is a move to undo, it moves to the next line where character is equals to move m is equals to move.history. This retrieves the last row from the stack. Reminder, if the player press W, we push S. So m now pulls the opposite of that last action. Next, move history.pop. So it removed the character from the stack. So we don't undo the same move twice. And finally, this is the most elegant part. Move tile, m and false. We simply executed the opposite move. Okay. It calls the same move file function we use for everything, but passes well false for the record move flag. This prevents the loop by passing false. We ensure that this undo action itself isn't recorded back onto the stack, which will create an infinite undo loop. This simply four-line function is all that's needed to create a robust and powerful undo feature. Now, outside of the main class, we have a few helper function that manages the game's menu. This is a show instruction function. It's a very simple function that does two key things. First, just like a display function, start with the system CLS or clear to wipe out the console. As the slide explained, this is a cross-platform command to ensure a clear screen on any OS. Second, it just uses a series of clear statements to print how to play, guide, explain the WSD control, the U key for undo, and Q for the quit. For the last is from the input buffer, like the 2, the user press on the main menu. Without this line, the screen.get on the next line will immediately read that old two and the instruction will flash on the screen and disappear before anyone could read them. So, scene.ignore clears the buffer and scene.get then properly pauses the program waiting for the user to press enter to return to the main menu. It's a small detail but it's essential for making the menu work correctly. So the next slide is for the play game function. Now let's look at the play game function. It's the engine that runs the full round of the game from start to finish. As you can see from the code, the first thing it does is to create a puzzle object, passing it the puzzle size that the players selected. It immediately calls game.shuffle to scramble the board and get a new solvable puzzle. After that, we enter the main game loop. This while loop is the heart of the function and continues to run as long as the game is solved, returns false. Inside the loop is very clear repeating cycle. First, it calls a display to clear the console and draws the board's current state. Then it uses cout to show the player their life stats, the move count, and the current time from the game.get elapsed time. It also reminds them of the controls. Finally, waiting for the player to enter the next command. This loop repeats, displaying getting input, processing the move until the player finally solves the puzzle. Next, we saw this login loop wait for the user's input. The slide shows what happens right after the player presses a key. This is the main if-else block that processes the command. First, it checks the move's Q and or the move the capital Q. It will, if the player wants to quit, it simply its return which exits the play game function and send the user back to the main menu. Next, it checks if else. Move is equals to U capital U if the player want to undo. Then call the undo move. It then decrements the move count. This is important to keep the stats accurate. If the player didn't quit or undo, it tries the else. If game.move tile move block, then it actually update the move count. Finally, if all those fail, it means the player entered an invalid key like Z or tried an illegal move like moving like a wall. The else block catches this, printing an invalid move. It thus runs that busy wait for loop, which thus pauses the game for a second so the player can read the error before the screen clears on the next loop. This single if else structure handles every possible command the player can give. Now we have seen the main game loop, and we see the player actually wins. As soon as the itself function returns true, the while loop finally breaks, and this is the code that executes. First, it calls game.elapsed time when last time to check in the final time. Then it prints a congratulation message along with the player's final stats, their total moves, and their total time. And finally, just like in the instruction menu, it uses the crucial scene.ignore and scene.get function combination. This pauses the screen and waits for the player to press enter. Once they do, the playing function ends and the program returns to the main menu. This block of code is what provides a clear, rewarding end screen for the player. Next, finally comes to the main function. This is the entry point of the game. The very first thing you will see is the sRandom time function which we have just talked earlier. It's a crucial one-time setup. Now, this ensures that we call the game shuffle. The shuffle is different every single time we run the program. After that, the program enter a while true loop. This loop is the main menu is designated to run the forever until the user actually chooses to quit. Inside the loop, the first thing it does is system serious or clear to wipe the screen. Then it just uses a series of CF statement to print that clean center title and the three main options: start new game, instruction, and quit. The loop then pauses at same choices, waiting for the user to type 1, 2, or 3. The rest of the main function is just an if-else block that look at the choice available and decide what to do next. Either call the play game function, the show instruction function, or to quit, or to exit the loop and enter program. Next, we will see this is the if block when the user is when the choice is 1, it will start a new game. The program first clears the screen and displays a new select difficulty menu, asking the player to choose 1 for 3 cross 3, 2 for 4 cross 4, and 3 for 5 cross 5. You can see in the screenshot. It then uses a switch statement to take the difficulty input and set the puzzle size variable to 3, 4, or 5. But the default case here is very important for the robust error handling. If the players enter a 7, this is an invalid choice message. Then, as the slide explained, it entered this for loop, which is just a busy wait loop. Its only job is to do nothing 1.5 billion times, which forces the program to pause for about a second. This is crucial so the user actually has a time to read the error message before the screen clears. After the pause, it hits the continue keyword. Continue tells the program to immediately skip the rest of the loop and jump right back to the start of the main while true loop, which redisplays the main menu. This ensures that the play game puzzle function, which you see at the very bottom, is only called if the player makes a very difficult choices. Now, the the choice are checked for 2 also. If the user has entered 2, it will just show the instructions. If the user has entered 3, it will just say thanks for playing and then it will actually return the value for the quitting and else it actually shows like this. This I have explained earlier in this game also. Now these are the important software development lessons that I learned from my project. First, I just learned how to use the object-oriented design, like how to use the puzzle classes, how to organize them, and how to use the private data and public interface. Next, I just learned what are the different types of data structures, like 2D boards and the undo feature, and the right tool, and what to use for. Like we have used a stack container for the undo feature. I've also I've also used I also understand the logic and state like how we are defining the game logic. The next thing is that I just understand how to use chrono for measuring the time and again and also I've used how to use it graphically. Sorry. I also understand what are the commands that we have used, like the system clear commands, the time formatting, how the NSI close, colors, and the robust input. This made me understand how we can actually make our display more and more visually appealing. Next thing is the game loop and shuffling, how to use and when to use the main and game loops. So this C++ project helped me to learn these things. Thank you. Now I will show you how my program runs in the terminal and how it looks. This is the main menu that we have discussed in our video. It actually asks for the from the user his choice that he will want to start a new game, he want to have the instruction, or he want to quit the game. I will just enter 2 for the instructions. It will tell about the control keys, what are their functionality, and also how to undo your move and how to quit the current game. Now it actually waits for us to enter so that we have to open the main menu. I will press enter. Now I will be starting a new game. It actually asks for the difficulty. The easy is for 3 plus 3, the normal is for 4 plus 4, and hard is for 5 plus 5. We will try second. Now this is how it looks in our screen. We can place some random moves like W. We have to use enter. Now we see that the W key, W tile is actually going upwards and there is a